this video, we want to design a rooftop solar PV project of 131 kilowatt. We are going to use Google Earth and PVSol for the design. So welcome to follow along. Whenever you start Google Earth, you will be greeted by this screen. That is, if you have not set a starting point. Before we can use Google Earth, we need to do some settings. So we start from, this is a sidebar. I can put it off and on. And then what we need is that we need to have 3D buildings checked and the terrain checked. Then we move to, let's look at what we have in the edit. In the view, we will remove the sidebar when we are just about to start what we want to do. Then tick the scale legend. Then tools, come to options, check the following, the two color, compress. Then we want to show latitude and longitude in decimal degrees. Then the units of measurement, we want meters, kilometers. The others are set like that. Apply, say OK to that. Then we move to our site. So I'll enter the coordinates here. These are the coordinates of where we want to go. And let's fly to our construction site. So yes, this is our building. The one we see at the center of the page. I can zoom in. I'm just scrolling the wheel mouse and dragging. I can now close the sidebar, okay, so that we have more space. This is where we want to do our roof solar PV project. So the reason why we are here is because we want to take the height of this building, and the best way is to zoom in and get the best angle of that. I can still zoom in further, maybe somewhere there. So to get the height of this building, I'll come to the tools, this one here, show ruler, and if I click on it, it is giving us all these options, but the one we want is not to measure the distance between 2 points, but say paths, measure the height and width of 3D buildings and the distance from point on buildings on the ground. So this is the one that we're going to use. I'll move this one aside. I'm just holding it with the left mouse and dragging it to the side. Then I want to measure from this position here to this position here at the top. Now realize I've not gone all the way to the top because we will be adding this parapet wall when we are doing the design in PVSol. So we note that distance. This is about 34 meters. Then we are done with Google Earth Pro. So I'll just close it and then we move on to PVSol. So when you are in PVSol, this is a screen that greets you and it opens up to collect the project data. And for example, here I'll just enter some names. So ABC 123, that is the number. Then of course this is PV circuits. I just put there. And our project name is Rooftop Solar PV project. The customer number, we can just put the same. Then we click on next. So these arrows here are to take you forward or backwards. If I click on backwards, this will take me to the opening page. But if I click on forward, then I can click on forward again to take me to the next stage. So it keeps on taking you to the next step. So our system that we're going to design is a 3D grid connected PV system with electrical appliances, and 3D is because we're going to use a 3D model building so as to place the solar array on top of the flat roof. Whenever you're starting a new project, you have the choice to either decide whether it is 3D design or use any other form, because you can also use other structures and which are not necessarily 3D. So in this case we want 3D, and then what it will warn you when you do that is it is asking you whether we want to switch to 3D design, and that is, we can affirm that. Now, because we have not selected the data, climatic data, we need to tell it where this design is going to be based. So for a new project, we must give it the climatic data. And you do that by going to this globe here and clicking. And since it is a new location, we will create climate data for a new location and give it the location coordinates. So I'll select this one and put the right coordinates, then click on start. So when I click on start, it should open this one here. It knows it is in Munich, and the location name is called Bon van Breatham. So that is a name. So it is creating the meteor data. So there the data has been put in. Then I can say OK. Then we come back to the design, the data will be brought back, and it has been done successfully. So we move to the next stage. Click on the arrow and we add on a consumption, and what we're going to add here is probably like 90,000 kilowatt per year. Yes, or even say 100,000 kilowatt hour per year. Say OK. Then we move next. So now here is where we're going to design the rooftop of the place where we're going to put the array. So I click on edit to allow me to do that design. So if I click on this small arrow here, it brings up this menu, and there's a map section. There you can import a model, or you can use these primitive designs or shapes. Okay, it has all these selections which you can select and use them for your design, but ours we want to use map section. And if you click on this area, it should open up the area that we want. Of course it is looking for this name, but we need to give it the coordinate so that it goes right into the area. So if I click on search, then our building is back here, and I need just to zoom in so that it fits into the screen slightly again. So there, I think that is the best we can get. So once we've done it like that, then we say select. So everything has been in place, so we can start the process of designing the rooftop. So the first thing is giving us options to add in some elements if we so wish, but since the place where the panels are going to be put is at the top, we'll only deal with the obstructions at the top of the roof. So I move on to drawing out the area of the plan of the floor. Then that sets out the other activities to be done on it. So this one is what we use first. So we are going to sketch a polygon and click on that. So to expand this, I just roll the mouse wheel until I get a size that I want. If I want to pull it, it is right side of the mouse, so I hold it down and pull it, then continue to expand until I get the size I want. So that way I can start drawing the polygon and clicking on here and pulling. Let me maximize this. So next point is here. The line will continue following. I'll just follow the edges. Now, one pitfall: do not put it very close to the outside of the edge, because then it will pick a point on the ground surface. So I'll continue like that. Just on the inside. So the area has been mapped out. To get out of that process, you right click again. So one thing you can do is also to make sure that these corners which have 90 degrees or almost 90 degrees are right angles. So I right click again and say make at right angle. So it will move around the structure looking for those angles. And as you can see, these ones have been put all over. So we are set. Yeah. Okay, to draw anything on the surface, we need to extrude this structure. So I'll right click and say extrude. And the distance, the height we are going to give is the 34 meters that we collected from Google Earth. So 34. Then we say okay, then we want it also to transfer the map section to roof structure. So okay. So now that is our structure. If I'll move around, maybe you can see how it looks like. Okay, this is just a view of how this thing looks like. So anyway, we continue, and to continue, next is that we need to activate this surface so that we can draw on it. Alright, that is a surface there. And we now want to draw these areas that are going to be mapped out from the areas of the module. So again, we use our polygon drawing tool, and we just go around marking the objects and making sure they are also right angled. And next we take the next one. Right angle it. And like that, we just continue. Make it right angle. Again, pick on this one Remember, once I finish drawing one, then I right click to get out of the drawing mode. Then make right angle. Again, this one here. So we look for another structure, this one here. There's a small structure here. Make right angle. So these structures need to also be extruded to some height. So I'll extrude this one, maybe to, and see what it is selecting, whether it is a skylight or not. I'll just put them to some arbitrary 3D object. So I'll get it like that and give it a height of say 2.7 meters, all of them. This one also extrude it, select it as an arbitrary 3D object, we don't know what it is, and I'll give it still say a height of 2.7, and so on. So I'll just continue selecting and extruding. Give it the right definition or the right naming. So give it 2.7. Ooh, 200 meters. And move here, this one we extrude it, and see also in this case also the shape of it is being transferred to the top of it. So I want it at 2.7 also. So all this on this side have been done. We move into here. This one is a short structure. It is I'll extrude it and put it as still an arbitrary, but maybe give it 2 meters or something like that, or 1.5. So the structures have been extruded. Next we do the restricted areas around maybe these structures. So I'll pick on that and I'll just mark out this area here and put out an area there. If I still want, I can also write it. Alright, and then we do for this central area here. I want to map the entire central area here. So following some of the shadows, I'll go there, go here, like that, follow here, and also up to this corner here, go around like that, up to here, to here, to this place here, and somewhere there, to here, and to here. So the entire of that central area is mapped. Right click on it, then we map the next side. Look at this shadow here, take it out. do this one. Okay, so I think the entire area has been mapped out. Now when we have done that, then I need to add the parapet wall. This building has a parapet around the entire structure, so this is a tool for the parapet, and I'll put it at, yes, that thickness, and put it to a height of maybe 7.5. Say okay, and you can see a wall has been added. You can see it when I go there, a wall has been added. Now once we've done that, then we move on to the edge distances, and I click on this, and it is asking for all the sides what edge distance. I'll probably give say 1.2 meters. I could have given less, but let's use that. Also some standards have a specification for how big that edge distance can be. So I close that, and you can see now that white stripped area around the entire building has been carved out. So next, once we finished with that blocking out of the areas, we move to the module mounting, and we have to bring in the type of mounting that we are going to use. So first of all, we need to the module, and what type of module do we want. So we do the module, and we want to select a new module from the database, and it opens with this, but the database is big, so probably let me try the Jinko Solars and go for say a 300 watt or 310 watt module. The equator number 305. Okay, I have this one, the 300 watt. So say okay. Then once the module has been set, we close this area, but we want it to be the horizontal formation, so close this one. Next we go to the mounting of the module. So we go to module mounting, then we select a new module mounting. But before we can select the mounting, we need to understand how to select the correct inclination of the mounting. So to understand how the optimum tilt angle for panels are set, the idea is to, when you want to achieve maximum power output from a PV panel, its tilt angle should be adjusted to a near perpendicular to the sunbeams. Now this is the equation here, and this equation we have that beta is the optimum tilt angle and phi is the latitude of the location. The tilt angle is always a positive value, so that the array always faces the direction of the equator. And we say that for arrays in the northern hemisphere, we subtract the 15 here becomes negative, then we get the angle, and the array must point south towards the equator. And for the arrays in the southern hemisphere, we add 15. Now that part becomes positive, so that we add, then we set the panels to true north, meaning the azimuth is 0. So for our site, these are the coordinates. The latitude is this figure, and the longitude is 11.580256. So if we fit in, because this side is in the northern hemisphere, we subtract the 15. So here is the equation. We find that it comes to close to 33 degrees. That is the inclination that we're going to have for the structure to hold the panels. And some other points also to note is that when you're in the equatorial band, say between 10 south and 10 north, the array should be tilted at a minimum of say 10 degrees. All right, so you need to put them at about 10 degrees, and this is to allow for self-cleaning of the arrays when it rains. Also, still on the equatorial band, the array can be oriented north or south with a little change to the output. That means you don't really have to worry about whether it is facing north or south, but you'll choose now. I think effectively when you're in the south, we've said point them to the north, but you can still have a structure which it will be on both sides, some facing north, some facing south. And we are saying a few degrees calculated from the above equation does not make any significant difference in the energy collected by the panels. So within margin, you don't really have to be vary, but the idea is you know how to get the angles from the equation that you have given. So we move back to continue in PVSol and continue to construct our solar project. So you can see the edges have been marked, and it is going to ask you which edge you are going to use to make the reference of the mounting structure. So here, the number of modules we want on the structure horizontally is 1. You can change this to 2 depending on how you want it designed. Part of these I'll leave as they are there, but the critical one is this one, because this is a mounting. So I'll go to calculate, and what I want is the resulting mounting should be the 33 that we had calculated in the presentation that we saw how to calculate the tilt angles. Then the orientation remains as 180. So this is how the mounting is represented. Then I say OK. Alright, so with that, the system is almost set to calculate or place the modules. So these are the final angles, how the modules are going to be on top of that roof. So the depth of row, then the mounting clearance distance from the ground, then the row spacing. It has already determined by itself automatically. So I say OK. Then accept here. Then we are finished with the mounting. Now we want to fill the area with modules. And there are several options here. The one we want is to cover the entire area with the maximum number of modules possible, and that is given by this here. So I click on it, and it's still confirming whether I have the right information. So I'll accept what it is giving me. So the modules are put in place. You can see them. These are the modules. Okay. Then some areas probably I'll need to clean out, or I can leave them, or then we see how it works out. So with the modules put in place, what you need to know is you need to simulate the shading frequency so that we take out the modules which will be inefficient or are shaded to more than 15%. So those which are more than 15%, we will take them out. So I'll run the shade frequency analysis, which I'll tick on this one. And it is going to move like that until day 65, checking the sun angles and how the shadows will be falling onto the modules. So the analysis is done. So we move closely, you can see reddish ones. We want to check the frequency that has been determined there. So if you go in, or if you come close to this, you can see this is about 42%. So this row here is very inefficient. This one is 21%, all of it up to somewhere here. So we'll cut off those ones which we think are inefficient. You can see this one up to here. This 11. Okay, so we need to start doing the cleaning, and when you start doing the cleaning, these figures, the coloring will disappear, but the frequencies will remain somehow. So in order to break like this row here, you use either this one to move them. So like this, I can start like that and pull this along. This action deletes. Yes, I want to delete. So I've double clicked to exit out of that process. So if I check the frequency again, if I just come over, so apparently the frequencies have been, all right, there they are, 0. Now it has cleared the frequency. You can see this is 15%, 13%, 9%. So I want to cut from here because these ones are very high, 14. So I'll break it from here, from this one here. I'll pick the breaking tool and just come, and where it turns red, you cut there. So then we can delete the entire row. This is 12.6. These ones are small, 6, 5.6. Now these ones are very weak, up to here, up to here. So again, I get the tool for cutting, and I come and break this thing somewhere there. Then delete these ones. So the process goes on like that. I'll keep on checking. So I think this side is finished. Let's look at this one. So at this point in time, let me save the work. I've not been saving. So save again. And let's go to this side and check these panels again. Okay, I think this process for finding the frequencies. So because the frequencies have disappeared, maybe I can either choose to rerun it again or proceed with what I have. Let's see how it looks like. So I'll remove these two. And this one. Okay, let me just remove that row. Yes. And essentially we are done with the cleaning. So here is being affected by this structure here. That's why we have very few modules there. So next we go to configuration and we click on this one, and we wanted to configure all unconfigured modules, and this is the best option rather than maybe taking on one then configuring one. So it will give us all the modules are going to be configured by this option here. So I click on it, and we need to select the inverters. So we see here the power we have here is 131 kilowatt P, and we need to select an inverter which will give us a DC AC ratio of 1.2 to 1.3. So if we calculate the power, the AC power of that inverter should be about 100 to 109 kilowatt. So we move to the selection to look for this kind of inverter, and then we see how the system is going to work on it. So first of all, we go to the selection, and then it will give us a list of the database. So this is what we get in the database. It is a list of inverter manufacturers. What you can see is that I've moved here before and highlighted some of my favorite inverters, and if I click one of them, you will see that what is unique is that some of these companies, they have quite a selection of inverters. So like in this case, the particular unique thing is that the MPP tracker, this is one, and you can see quite a range of AC power output. So depending on what you want, then you select there. As you go on, let's see another one. Yes, you can see here that there are some with 2 MPPTs and so on. Let's look at this one, for example. they are some with a high number of MPPTs, and also the power range is quite good. So like that, it's good maybe to select about 6 to 7 inverters. That makes it easier for the software to go through the iterations for identifying the inverter that you're looking for. So maybe I'll start with the probably a Traco. Let's see what we have here. These guys. And what we have, as we have said before, we are looking for an inverter between 100 to 110 AC output, and probably with several MPPT connections. So in this case, maybe one with 40, of course the combination, 3 of them probably around 110, 120 there. Let's see Canadian Solar what we have. Probably this is AC power rating, and I'm also looking for one with a high number of MPPTs. Okay, maybe we get 40, maybe this one. I'll try, let me go to Growth, and Growth have quite a number, so we look for one maybe at 40 kilowatt. Let's see what we have here. That's 3650. Maybe this one here probably can work for us. Is there another? Let us look at maybe Huawei, then we try to see if we can get one of 40 watts, if there is. Probably this one. Okay, we can see as you tick them, they come up here. So probably I remove one. Let me remove the Huawei, or I leave it that because we already have 6 inverters there. Then once I've done that, then I'll say select. So when I say select, then it will look at the ones I've done, then try to get me the configuration possible out of those that I've selected. So it's going through the process. So you can see here it has brought this inverter, and this is what we are going to use. So we move forward with this. I say OK and proceed with the process. The configuration has been done. So we move to the next, which is a cable plan, still on that upper menu. And it gives us this picture. So we can click on this area here to show us the string diagram. And that's how it looks. Detailed though, but very difficult to follow here, although the plan will be set out later, but that's how it looks like. So we can choose this will be included in the report, so I can leave it here, so I can just close this. Then when we are through here, let me save this. Then we need to go back to the design. So I close this window, then it takes us, it will want to confirm. So should this data be adopted, The answer is yes, because we want this data now to be taken into to continue with the design. And it states here the module shading ratios have to be determined in order to run a yield simulation with shading analysis. So yes, I want it to continue, so let me just accept that. And it is going to take time doing this simulation, but let's just see what we get out of it. So from the time, you can see almost 12 minutes, so I'll speed up this process. Then we come back and continue from there. So the simulation process is over. We move to the next stage. I'll close this window and move to the next stage. Then it is asking whether to adopt that data. I'll say yes. Then now we move to the next stage. So in the next stage, now we are going to define the symbols in the circuit. You can see this is a circuit, the basic circuit, and we'll go for the detailed option so that it puts the initial information there. You can see that is our inverter. There are 3 of them, and when we have 3 of them, they must be synchronized. The communication cable between the 3 must be connected so that they are able to deliver the 3-phase as combined. So here we have the side of the AC, then we have the side of the DC, and we have the AC cable immediately from the inverter, and this is the AC cable from the grid, and these are the array and string cables. So what I want to do first is to start from the side of the feed-in meter, and we see here this is a panel which has been put there. That is a kilowatt meter. This is a bidirectional meter. So the way the bidirectional meter works is that if there is excess power than required, it will be fed into the grid, and when there's a shortfall, the power will flow back to the system. We want to introduce the fuse, although the panel has been put there, but we can show some of the things. We can put in a fuse and a disconnect switch so that we can be able to isolate the AC side. So I'll add a simple circuit for the fuse, then add the load break switch, also I'll need side protection, and I'll need the load break switch. Where is that? This one. So we add it. So we see these things. So let me put the side protector close to this side. So I highlight it, then use the up arrow to move it to close to the on this side. I think with those symbols that side is set. Now I need this inverter, the AC cable from the inverter. I need to put another switch, and we come to these areas here, and we need to give some distance, so maybe like 5 meters, so that we can be able to see the wattage. and you can see there's a lot of power being lost there. So I can reduce, or I can increase it maybe to 10 millimeter. We see still there's still some amount of power, but this is at 0.22%, which is okay. But then I need to add a load break switch maybe after the inverter, so I'll add a symbol here, and that is a load break switch. This one. So there it is, just to make sure that we disconnect power before it goes to the other side. Then we now deal with the strings, and we move down this list. So the good thing with the string is once you do one, then it can be copied using this button here. So we are going to select, there are 6 of them, and this thing is repeated for the 3 inverters. So when you do one, then it can be copied in all the 3. So the size, maybe I give this one some length, a length of maybe up to 50 meters. Okay, so the loss is fairly small. 4 millimeter cable also is being used. Now this thing being expansive, maybe let me increase it up to, say, length up to 80 meters. Okay, and the percentage is still fairly okay. You can see there that is 0.38. So I leave it at that with the 4 millimeter. Then we add another symbol. We add symbols here. What I want is I'll add a fuse, then I'll add a load break switch, I'll add surge protector, so okay, I think I've added the wrong thing. Edit, remove this one. I want to add load break. That is to act as a disconnect. So we move the switch to the far left. So move this one. So essentially those are the things I want to put there. You can have others, but these are the basic components that you'll need to have there. Then once I've done that, I need to copy them now. Clicking on this will copy it in all the other trackers. So you need always to keep your eye also on this area, because sometimes what you're seeing here is just for one. There could be, if we had other inverters, then they could be here, and then you need to select them and go through the process again. So you see all these have been put in place, and we're being told that is times 3, and essentially I think we leave our design there. Okay, so we move forward. So this is the layout. This will be included in the diagram. You can also export it as PDF to say save it like that, and you see it, that's the diagram there. So we move on. By clicking next. Now with this part having concluded here, is essentially we have finished with the electrical part of the design. So the next part we are going to is financial, and this one is subject to several things. Part of the information is depending on how you want to view it. So I'll give in some arbitrary figures. So like here it is, say, like about 7-8 cents or something like that per kilowatt. So the price of electricity sold to third parties. So if you're producing it, the excess energy that you're going to sell, that is probably the price that you're going to use. Then there are some feed-in tariffs, for example, which are here. If you are in these areas, then probably you know what they are. So inflation rate, maybe I'll put, say for example, maybe 2%. All right, and also give this one 2%. This is inflation rate for feed-in and inflation rate for on consumption. Right, so just like that. Then I go next for it to start doing the simulation. Maybe what I can change also is the number of years. So I'll stop this, then we start again. Just come back here, and then we go to this, and what I want, keep in that information, but edit this one and let me put it at 25 years, then close, and then try to run the simulation again. So we go forward. So the figures used here are generics. You can adjust them. Of course, we have not calculated the cost of this system, but you can adjust now, put in the right figures to make sure that you get the right simulation for the financial analysis. So the simulation is done, and we now move to the reporting. Now you can see this is some of the data that has come here. It's showing us the yellow is generated, the gray is on use. So you can see we are generating a lot of power, which part of which is going to the grid. This is the total amount that has been generated. Let's look at that. This is just how the coverage of consumption is. A lot of data here, so a lot of diagrams which have been generated based on the information that we've given. Then there's a financial cash flow. So as I said, maybe the investment, this one needs to be worked on, especially if you are doing it for a serious project, so that then you get the actual figures flowing into the program. So what it is saying here, that after the 13th year we should start break-evening and getting our money back. And you can see that the amount, based on the data that we have given, this is quite a good investment. So this is just another representation. And finally, we go to the report and presentation. So that is a report. We can export it, and we can choose say another one, because I've generated another one. So this is our report. can see our site there. The data that comes out, that is a array power, and this is the area that we have used on top of the roof. Then this is a schematic of the design. So the information comes out. We are given 100,000 kilowatt per year. Then we go down to, of course, that is our site, looking quite impressive. And a lot of data which have been simulated. So the generation, the annual yield for the PV, and a performance ratio of 81%. So as we move down to the report, what we see here is that we produce about 141,788, out of which we use 36,684, and the balance of 105 goes to the grid. And also, at the time when you're not producing, this amount 63,340 comes into our use. So these are more graphs and the yield in accordance with the calculations. This is a monthly, and we see our peak yield is around June of 181.67 kilowatts. This is another presentation, and this is a cash flow, which I've said you can put in your exact figures to generate the actual amount. So with our generic data, break-evening after 13.5 years, then we start gaining from the system. And this is your electrical diagram. And finally the layout of the system. And also I think the cabling plan is at the end. And this is part list, although not detailed, but it represents the major components of the system that have been used in the design. So with that, we have concluded this a design of using PVSol combined with Google Earth to give us a design of a solar PV project on a rooftop. So we thank you for your time, for having followed the presentation up to this point. So keep it here for more videos like this. Thank you once again.